Okay, so the first part of the experiment involves filling out the table with the 3 resistors. So you want to get your 3 resistance values, and we're going to use the digital multimeter to get precise values for the resistance. We're going to set it to 20K because we have multiple resistors and at least one is going to be larger than that 20K. So here are our 3 resistors. So we want to order them. We want R1 to be, for the sake of simplicity, we want R1 to be the smallest one, R2 to be the middle one, and R3 to be the largest one. We will start with this one. And this is the resistor we used in the last experiment. So it should be about 1,000 ohms. And so this is in kiloohms. It's 1.06 kiloohms. And so that's going to be our first one, I believe. That's going to be R1. Then the second one, or this one here, is 1.67 kiloohms. And our third one, and again, when you're measuring resistances, you want to make sure that they're out of the circuit when you have them connected. So that comes out to 3.65. And again, that's kiloohms. So we basically have small, medium, and large resistance, although they're all kiloohms. And we're going to be then measuring current in milliamperes. So we're going to set up our circuit in series and in parallel. So we're going to start with our resistors in series. So you notice we have the smaller connecting wires, and we have these Velcro pads that we can attach the resistors to make our lives simple. So we have a current coming from the power supply, and we already have a voltmeter connected to it, but we haven't turned anything on yet. So our circuit is going to come into the first resistor, and then we're setting up this wire so that it then goes through the second resistor, and we're going to set up another wire so that it goes through that wire and then across the third resistor. And then it goes back out. So, and just to get the voltmeter out of the way first so you can see the circuit without it getting too messy. So this is how the circuit looks in a nutshell. What we are going to do is 4 things. We are going to measure the voltage in 4 different locations, and we are going to measure the current in 4 different locations. So we're going to call the current going in, so we're measuring at 4 different locations. So we're going to call point A the current before it goes into the first resistor, point B after the first resistor, point C after the second resistor, and point D heading back out. And in theory, in a series circuit, they should be equal to each other. So, whereas the voltages in theory should add up to the voltages across each resistor, in theory, should add up to the voltages across the power supply. So what we're going to do is set up our voltmeter. We want it to read 20 volts, and right now there's nothing on. So what we're going to do is turn our power supply on and adjust. Now the experiment calls for 20 volts. I'm not sure this particular device can get up to 20 volts, and it cannot. So we will do 13 volts. As best as we can do. So that's 13.03 volts across the across the power supply. So now we're going to measure the voltages. We'll do the voltages first because they're simpler. And so we want to measure across the first resistor, across the second resistor, and across the third resistor. So let's see if I can get these steady. All right, so I'm getting a reading of 2.15 volts. So that's V1 or VR1. And now we're going to do this and we're going to need to switch them so that we don't get a negative number. And that is 3.39 volts. That's across the second resistor. And then the third one, which is the biggest, oh, we got to flip them over again. That is 7.40. So that is the voltage across the three resistors. So you're going to put those voltages along with the total voltages in the table. And you're going to do this. Now we're going to work on the series, the current in series. So we're going to start at point A, which is right in front. So we're going to need to disconnect this, disconnect the lead coming from the resistor, because now what we want it to do is go into the, and I'm going to put this down for a second. What we want it to do is go into the ammeter and then out of the ammeter and back to where it was in the first place. And so we're going to set up the current and okay. Oh. All right, and this is going to be in milliamps. So this is 2.0 milliamps. And so that's the current at point A going into the first resistor. Now we are going to measure the current at point B, which is between the first and the second resistor. So we're basically need to put this down again. We're going to replace our connection here. We're going to pull out this small connector, and we're going to reinsert the current or the wires from the ammeter. My apologies for my hand being in the way. So we're going to put the red in the front and the black in the back. And so again, we get our current reading, which is 2.01 milliamps. So at point B, it's 2.01. So you have your current for A, which we recorded, and your current for B, which we recorded. And now we're going to move on to point C. So we reconnect this little wire, and then we're going to disconnect the other little wire. And so this comes out. And now we're going to reinsert the current in the same way. So we put red in the front, heading straight back to our multimeter measuring current, and black in the back. And we check our current reading again, and we're getting 2.01 milliamps. So again, this is not unexpected. We don't expect the current values to change, but we're verifying that they don't change. And so we've got one last measurement for that, and then we're already halfway through the procedure. So you plug this in, and so we disconnect the wire going back to the power supply. We are going to connect the red leg in front, as we did before, and now we're going to connect these two black legs together. So I'm going to need to put this down again. So now I've got the black legs connected together, so it's going back to the power supply. And so this is the current at point D, and we're getting the same 2.01 milliamps. So that was what we had before. So we fill out both of these tables with the data that we have. And then we're going to the parallel connection. So the first thing we're going to do is shut off the power. And maybe we should bring this down again. So now we're going to reconnect our circuit. but we're going to do it slightly differently. So we have our 3 resistors. So the current is coming in this way. We are going to want small connectors connecting the front ends of each of the 3 resistors. So we have a small connector here and another small connector right above it. So the current is going to split out and go to each of the 3 resistors and then across. And so we want those 3 resistors to reconnect on the back end. So we have another little wire connecting like this. So we have wires connecting the front legs of each of the 3 resistors together, and we're going to have wires connecting the back legs. So we need one more small wire. And that connects like this. And then the last thing we're going to do is connect the wire that goes to the negative terminal of the power supply back up. So that's our basic parallel circuit. So the current comes in from the positive side, it splits up, goes across all 3 resistors, then recombines and goes back out. So now we're going to set up the power supply just like before, and so we're going to connect our voltmeter. And so we're going to start by connecting to the power supply. So we're going to set it up to be 13 volts again instead of 20, because this particular power supply can't go up as high as 20. So we're going to turn it on. You see the red light is going. And we're going to set up the voltage across the power supply to be 13 volts. And so you see your table. So we're going to do the voltages first. So it says V supply, so that's 13 volts. So we're going to disconnect the leads to the voltmeter. And I apologize for my dogs. So we're disconnecting the leads to the voltmeter. And we're going to do what we did before. We're going to measure, let's get things untangled here. We are going to measure the voltages across each resistor in turn. So we do the first one. So we get 12.94 volts there. We go across the second one. We get 12.97 volts there. And we go across the third one. We get an even 13.04. Well, it was even. Now it's 13.03 volts there. So in theory, they're supposed to be the same. They weren't exactly the same. That's something you can comment on when you do the experiment. And so now we are going to measure the current in 5 different locations. So first, going in, which is the total current, then the current through the first resistor, the current through the second resistor, the current through the third resistor, and then we're going to measure the total current going back out. And we're going to enter those in our those values in our table. So we will move this 1 voltmeter out of the way, and there should be an alligator clip here somewhere, and there is. Okay, so we'll start with the total current in the front. And again, we're going to be measuring in milliamps. So we're going to just disconnect these two. I'm going to need to put this down again for a second. So we have the red clips leading in, and we have the black clip put there. And we're off the 20 milliamp scale, so we're going to go to 200 milliamps. So we're at 23.4 milliamps. So that's the total current measured at the beginning. So that's going to be I total A. Now we need to measure the current going through the first resistor. So we have this junction here. And so we're going to, you notice that we have the plug coming from the positive terminal, this wire going to the second resistor, and then going out to the first resistor. So what we're going to do is clip these two together. So we clip these two wires together. And now what we're going to do is clip the positive end of the ammeter there, and then clip the negative end to the back leg of the first resistor. So now we're measuring the current going through that first resistor. And we bring it over here, and it's 12.0 milliamps. So that's I1 up there. Now we need to reset everything. So we take the, disconnect everything, reconnect the way it originally is without inserting the ammeter. So we figured out how to get that first current reading. So now we're going to move on to the second current. And so you see you have both these small clips together, and then they're going out into the second resistor. So we're going to pull those out, do that carefully. We're going to connect the front leg to the ammeter to both these connections. And let's see if I can just sneak that in. And then we are going to clip the back leg. And if it's done right, you should have a current reading here, and you do. So that's 7.7 milliamps. And so that's the current. It's coming out the positive through the ammeter and then across the second resistor. So that's I2. So that goes in here. And then we once again want to reset everything. So we're going to unclip the multimeter or the ammeter. We're going to reconnect these two we're going to reconnect those two small wires. And now we're going to the third. We only have one connection going into that resistor. So we can pull that out, and we connect the red leg of the multimeter to that, and then the black leg to the front end of the resistor. And now you get the current going through the third resistor. So that's 3.5 milliamps. So you have your I1, I2, and I3, and in theory, they should add up to the total current. I will leave it to you to fill up the table and see if that's the case. And then our last one, we want I total at point E. So that will be on the way out of the circuit. So that's right here. So this will be our last measurement. And so we're going to put the red here, and this should agree in principle, should agree with the first reading. And you're getting 23.4 milliamps, which I believe was your first reading. So, but you can double check that if you didn't already write it down. So you have your I totals and you have your V totals. So what are you going to do with all that information? So you measure the voltages and you have the currents. You're going to figure out the total resistance from V total divided by I total. assuming you're getting reproducible results, and then by the equations for each type of circuit. So you're going to figure out the total resistance for the resistors in series. That's R total is equal to R1 plus R2 plus R3. And then for the resistors in parallel, it's the inverse sum relationship. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And again, so you can figure out, so you calculate the total resistances that way, and you calculate the total resistances from Ohm's law, which says R total is equal to V total divided by I total. And do your results agree with the uncertainties? So you're going to need to calculate the uncertainties as well, and then see if your results agree within those uncertainties. And if they don't, try to explain why they don't. Okay, so that's all for this experiment. This is relatively quick, this one. So until next time, I will see you. And if you have any questions, don't hesitate to email me. Okay, thank you very much.